DelTech Chem 100, Chem 110, Unit 1 continued, measurements and accuracy versus precision. So before we talk about accuracy and precision, let's just talk about what measurements are in science. Definition would be something that determines the quantity, dimensions, or extent of something, usually in comparison to a specific unit. And that means that the measurement should have two parts, a number and a unit. There are a few quantities that are measurements in science that have no units, but the vast majority have a unit. So types of measure come into two categories. Qualitative, where you're using a description without numbers, and quantitative, where you're using a description with numbers. So examples would be 4 feet. This is quantitative. It has a number in it. Hot, it's qualitative. It's just description with words. 100 centimeters. Well, you have a number and a unit. So it's pretty obvious that that's a quantitative measurement. Extra large. Well, what is extra large? It's relative to what? You could have an extra large jelly bean or an extra large planet. Okay, they don't mean anything specific. It's always relative. So we like to deal in quantitative amounts in science because quantitative amounts with a number and a unit can be reproduced. If you say hot, I don't know what hot means. Are we talking about hot tea versus cold tea? Or are we talking about hot molten steel? So it really can depend on what the context is. So quantitative is always going to be better. It's reproducible. So in terms of looking at measurements, we have two words to describe this. And in English, frequently these words are confused with one another, but in science they have very distinct definitions and do not mean the same thing. They tell us how good the measurements are. The first one is accuracy. This is how close a measurement is to the actual value, the true value. And how far away you are from the true value is referred to as the error. Sometimes this is done in terms of percent, so you might talk in terms of the percent error of something. So say you were expecting a value of 100, that's the true value, and you only got a 90, that's a 90%. You're 90% of the true value, therefore you have a 10% error. Precision. Precision is how close measurements are to one another. It is the deviation of each measurement. In other words, how reproducible your measurements are. It has nothing to do with the true value is. It tells you how good your measuring system is in terms of being reproducible. If you get the same answer each time, they could be correct answers each time, they could be incorrect answers each time, but how tight those measurements are to one another, that's a measure of precision, and we use the mathematical term of standard deviation or variation to look at precision of measurements. So here are some bullseyes with shots that are taken shown in red dots here. And if you look at each of these are a different combination of whether something is accurate or inaccurate, and we're also looking at whether it is precise or imprecise. In other words, high accuracy versus low accuracy on the top, and on the side, high precision versus low precision. And if you look at the upper left-hand bullseye, this is a situation where it's both accurate and precise. Accurate because the shots are close to the bullseye. That's the true value. The actual value is the bullseye here. And the fact that they are tight, they're close to one another, that tells you it's high precision. Now, if you move over to the upper right, you see that the shots are close to one another, so that's high precision, but they're all far away from the actual bullseye, so that's low accuracy. Inaccurate. If we look in the bottom left, here's a situation where they're relatively accurate. In fact, the average accuracy of these 4 shots is right in the center. So it's very high overall accuracy, we would say. The individual accuracy varies a little bit, but the overall accuracy, the average shot, is dead center almost. So that's a high accuracy in terms of overall accuracy. The precision, not so good. They're fairly spread out. And if we look at the bottom right, there we have low accuracy, none of them are near the bullseye, and low precision, they're not close to one another. So remember, for accuracy, you need a true value and you need to be close to it. For precision, you need to be next to each other, which means you need more than one measurement. So here are some examples. Here are different examples, and let's talk about it in terms of a few different parameters. We have individual accuracy. So moving from left to right, we'll call these 1, 2, 3, 4, 5, 6. You'll see in the first case, the individual accuracy of each shot is pretty poor. The second one, they're all pretty high. The third one, they're all pretty low. The fourth one, they're all pretty low. The fifth one, they're all extremely high. Well, it's just one shot. It's extremely high. And the last one of them is high and the other two are low. So individual accuracy will vary with each individual measurement. If we look at the overall accuracy, now we're looking at the average of these shots, the center of the shots. In the case of 3 shots, that would be the center of each triangle. If it's 4 shots, it would be the center of the quadrilateral. So the overall accuracy in the first one, you can see, is very far away from, the center, so therefore that's low accuracy. If we look at the second one, the center is right in the center of the bullseye, so that's high overall accuracy. The third one, they're all far away. The average is far away, so it's low. In the fourth one, they're all far away individually, so it's low individual accuracy, but the average shot is right in the middle. So the average accuracy, the overall accuracy, is quite high, even though all of these are terrible shots. The fifth one is a single shot that has both high individual accuracy, and since it's only one shot, it's also going to be high overall accuracy. And the last one, while we have one individually highly accurate shot, and 2 poorly accurate shots, 2 low accuracy, the average is also fairly far away. The center of that triangle is not very close to the bullseye, and therefore that's a low overall accuracy. And of course, the third parameter to look at is precision. Precision is how tight they are to one another. In example 1, you can see they're far away. Example 2, they're close. Example 3, they're close. So those are high precision. Example 4, they are very far away from each other, so very low precision. But example 5, there's only one shot. There is no way to measure the precision. Therefore, the precision is unknown. We have no idea what the precision is because we only took one measurement. And in the last case, our precision is low because the 3 shots are far away from each other. So, in review, accuracy, whether you're looking at individual or overall, is high when you're close to the target. It's low when you're far away from the target. It's unknown if you do not know where the target bullseye is. Precision is low if they're not close to one another. It's high if they are close to one another. And it's unknown if we only have one shot and there's no way to know how close it would be to the next shot because we haven't taken it. So here's some numbers with actual units. So these are actual measurements. And let's look at the first one, 10.72 meters, 10.73 meters, 10.74 meters. So, asking the question, let's look at precision first. Are they close to one another? Yes, the precision is quite high. Are they accurate? Well, what do you need for accuracy? You need to know what the actual value is, and you were never told what the actual value is, so this is unknown accuracy and high precision. Look at the second example, 56.695963 seconds. If this was in an everyday life situation, somebody would say, oh, that's very precise or that's very accurate. Where in fact, we have no idea if it's accurate or not because we don't know what the real value is. Maybe the real value is exactly this number. Maybe the real value is 4, in which case the accuracy would be far off, very low accuracy. So we have no way of knowing. And precision, we always need multiple measurements for precision. So we don't have any idea of the precision either. Let's look at the third example, 45 mils, 78 mils, 114 mils. These are milliliters, sometimes referred to as mils. These are 1,000th of a liter, also known as cubic centimeters or cc's. You may have heard that term. And so the true value in this case is 8.6 milliliters or 8.6 mils. And you can see right away the true value is completely off from all of the values. In fact, it's much lower than all of the values. So not only are all of the individual values far from the true value, but the average, even without a calculator, you can tell that the average of those three values is going to be very different from 8.6 mils because they're all way too high. And as such, we know that not only is the individual accuracy of each of the three measurements very low, but we know the overall accuracy is also low. And we also know that these measurements are nowhere close to one another, and therefore precision is low as well. Looking at the fourth example, 65.85 grams, 65.83 grams, 65.84 grams, and the true value is 48.56 grams. Well, right away we notice a couple things. Number one, we notice that all three measurements are close to one another. That means high precision. But we also know that none of those numbers are close to the true value. That means we have low accuracy. Remember, accuracy is how close you are to the true value, so you need a true value. Precision is how close you are to each other, and that means you need multiple measurements. Now, looking at the last example, $15, $20, $55, and the true value is $30. And we can quickly see a couple things. Number one, these three values are nowhere near each other, so we immediately know precision is poor. The second thing we notice is none of these values are that close to the true value, so the individual accuracy of each of the three is also very poor. Low accuracy, low individual accuracy, low precision. However, if we take $15 and $20 and $55 and take the average of those three numbers, how will we do that? Well, we add them up and divide by 3 since we have three numbers. So that would be 35 plus 55 is 90. 90 divided by 3 is $30. So our average value is exactly the same as the true value. So while the individual accuracy of each of these dollar amounts is very low, the average is exactly correct. So the average accuracy is extremely high. Unfortunately, the precision is also very low.